Well, good morning, everybody, and welcome to our webinar, Meeting the Challenge of Cloud Native Security. Just to talk through our agenda today, I'll do a quick introduction to the session today, and as this is the first of a series of webinars we'll be doing, I'll talk through the rest of the series briefly as well. I'm then going to introduce our panel for our discussion today. And let them introduce themselves to you and give them and let them give a little bit of background about themselves. We'll then have a short presentation that Clayton, one of our panelists, will give, just setting the context of what we're talking about in a little bit more depth. We've got a great case study that we're going to talk about that Mike Bidwell from Travis Perkins is going to talk to us about in terms of how Travis Perkins have tackled the challenge that we're talking about today. And then the meat of our session today is going to be our panel discussion between Clayton, Mike, Sajindra and myself, where I'll be asking a series of questions to help them discuss and unpick this particular topic for us. There's also the opportunity for our audience to jump in and ask questions when we get to that point, and I'll tell you when we arrive at that point, but if you can post your questions and your comments into the Zoom chat, please, and we'll pick them up as we go through. Just going to admit a couple more people that have joined. Okay, so let's set the scene then for what we're talking about today and over the coming series. Well, we know that people are very concerned about cybersecurity, but how concerned are they when we actually start to talk about cloud and cloud native and cloud adoption? Well, it turns out that people are becoming even more concerned about cybersecurity. You can see a couple of stats here. 94% of organizations are moderately to extremely concerned about cloud security, and 70% of organizations hosting data or workloads in the public cloud experienced some sort of security incident in the last year. Hackers are now really beginning to exploit the vulnerabilities of the cloud. In the past, security has traditionally focused on in-life operations and perimeter security. You know, if we build bigger and stronger walls, we can keep the intruders out, basically. But cloud native applications are much more complex in the way that they're architected, designed and deployed, and so the challenges related to them are growing. And we've also adopted a model in recent years. Instead of that kind of classic waterfall model or the more sort of agile approach, we've now moved to a model of continuous development and deployment, and this also introduces more challenges in terms of security and how our software is developed, deployed and operated. So in this series, we'll be discussing the challenges, exploring the contradictions, looking at some of the potential solution options and really exploring innovation and ideas for how we can tackle this particular topic of cloud native security. And just to give you a bit of a taste as to what's coming over the series, first of all, why? So today we'll be thinking about why is cloud native security so hard? What is it that's making it more challenging? We'll then be thinking about having the right tools in place to be able to ensure that we are doing cloud native development in a secure way. We'll be looking at tool chains and secure DevOps. We'll then be thinking about how we modernize legacy systems. What are the particular challenges and approaches that are needed for that? And then finally, we'll be thinking about innovation and how we can innovate in terms of cloud security when we're securing our software as a service applications and platforms and systems. So that's a little bit of a taste as to what's to come in the future of the series. But what I'd like to do now is begin by introducing our panel for the day, our panel of experts. So I'll start with Clayton. Hi, Clayton. You were the CTO of a digital banking platform and moved a data center into the cloud. So tell us about yourself and that experience.
Yeah, just briefly in the few seconds I have for an intro. quite a journey. Actually, when we built our digital banking platform in 2012, we did that on a Microsoft stack, leading edge at the time, actually, web application built for virtual infrastructure in a secure data center. And between 2012 and 2020, we went through this journey of migrating our web application into a cloud native architecture, microservices, software architecture, and also taking advantage of the cloud services that are available. We ended up migrating onto AWS and moving to a continuous integration, continuous deployment pipeline. So I've got kind of the scars to show what it takes to go through that legacy application modernization and migration onto the cloud. And one of the most challenging things about that journey is security. So I look forward to talking with everyone about the journey, but also about what we can do to meet the challenge of secure cloud native.
Fantastic. Thanks, Clayton. Welcome. Hi, Mike. Mike Bidwell is the Head of Governance, Risk and Compliance at Travis Perkins. Mike, tell us a bit about the importance of cloud native development at Travis Perkins and the importance of security in your role, please.
Yeah, absolutely. So as a group, we're making a strategic drive to cloud first, as well as strategic drives in an increase in our digital integration between the group. So we're making much more heavy investment in this area. And obviously to enable us in that area, we need to deliver secure systems, being primarily a retail business. There's a huge concerns around reputational, PCI compliance, doing contracts with government work as well. We have to be concerned with cyber essentials. So visibility on our cloud platforms is now becoming more and more of an issue, especially with the upcoming changes into the cyber essentials requirements. So we're making huge gains in that area to align what we do in security to what we do alongside the business strategic movements.
Yeah, fantastic. And we know we're going to be talking a bit more in depth to you about Travis Perkins' approach on this in a little while. So excellent. Great to have you on the call, Mike. Thank you. Hi, Sajindra. So Sajindra has held critical CTO roles for Deutsche Bank, fintech companies, and he's also in a new CIO role as well at the moment. So tell us a little bit about how cloud native security has been relevant to you in those roles, Sajindra.
That's a good question. Thanks, Matt, for the inviting to the session. So I think during the last 20 years, I think I have seen like different dimensions or different levels of adoption of cloud technology. So starting with first, I would say the more lower level infrastructure service adoptions, like that's how AWS, Azure, and maybe Google Cloud Platform grew as well. And from then growing from that, where we as consumers use virtualized infrastructure, and started moving to the next generation of cloud technology, mostly looking at more service-based or rather microservice-based, moving into more virtualized containers, cloud scale technology. So that brought a different dimension of security as well as complexity. Working within the financial services, the trading domain for the last 20 plus years. So it's quite critical that the security aspect is really critical. The data, client data, trading data, information. So it's very critical. So, and how that traverses through the network is critical when you run your infrastructure, your code in shared setup, like in a cloud. So the security aspect in a cloud native environment has been very, very relevant, and it's only growing more.
Fantastic. Thanks, Sajindra. Well, welcome to our panelists. So next in our agenda, we're going to think a little bit about setting the scene or setting the context for our discussion today. So I'm going to hand over to Clayton, who's going to give us a little bit more of an insight and in-depth thinking around this whole space. So Clayton, over to you.
Thank you, Matt. And kind of following from your intro to the series too, which is quite good and summarized it, we start thinking about this challenge or these problems of secure cloud native top down. One observation, which in some ways is quite exciting, is that application development and operations, in my view, is going through a real revolution right now. Quite amazing, actually. One forecast from Gartner says that in 2025, so in 3 years, 95% of applications will be built using cloud native technology. So the entire industry is moving into what is called cloud native, and I'll try to define what that means in the next slide. But the reason I say it's a revolution is that the methods that we use both to architect the web application, what's known as microservices, how to build it and test it, the quality of the application and the security of testing it for the security of the application, and then deploying it and running it in the cloud are all massively different. They're massively different from the way we built applications just 10 years ago. And so with this change, and look at it from top down, with this massive change in how we're deploying web application technology, and given the fact that the changes are actually quite technical and complex, comes increased risk. There's increased quality risk. There are people, process, and technology issues all around kind of coping with this change. The one we're focused on here, of course, is security. So in the increased security risk, traditionally, a lot of investment was put on network security. So think firewalls, network monitoring, certainly the user login and password, and then multi-factor authentication, and then biometric authentication, and encrypting data were all part of the mix. But now in cloud native, we've got a much more complex way that we're building applications with many more moving parts. And in addition to that, it's all moving much faster. So the continuous integration, continuous deployment pipeline, the whole idea there is that we're increasing the speed, which actually reduces the amount of time for things like testing and ensuring that whatever has been built is very secure. So we have to do all of this at a much increased speed. So the top down, that is the overall context. Now, if you go to the next slide, Matt, and we'll drill into this a little bit. We talk about cloud native, and I know I'm simplifying here, so just bear with me as we go top down. But I like to think of defining cloud native as applications that are built and operate on these kind of 4 basic principles. One is that the software is architected using microservices, kind of a new term for service-oriented architecture. But that composition is much finer grained than the SOA applications that we were building, say, 10 years ago. And key to microservices, and also key to security, is that each of those services, each of those microservices manages its own data. And when you think about security, data security is critical. So how we secure that data, keep hackers from stealing it, from breaking into it, how it gets encrypted, is all up to a microservice that is responsible for that. And a modern cloud native application can be composed of thousands of microservices, each of which now is responsible for its own data security. You can see the problem compared to, say, a more traditional application that's built on a single monolithic, say, relational database. And that had to be secure, but that was one database. And now we're talking about literally thousands of different persistent storage. Containers and orchestration, if I put those together, are the technologies that make cloud native possible. And it enables, obviously, the application to be deployed very quickly, very efficiently, doesn't require human operators, in case of containers, to set up the server in its operating system. But the human operator has been replaced with, in this example, say Docker software, a Docker daemon. And that Docker daemon has root privileges, which means it can do anything that it wants. So you've got to make sure that the way in which Docker operates is as secure, and in a sense, because it's all kind of happening behind the scenes, even more secure than the human operator, which by itself is a challenge. Orchestration and using Kubernetes is similar in that, kind of in my simple view, what it's doing is it's setting up the network connectivity between the servers and the applications that are running in containers. And that also, that network security, the ability to scale new servers, all involves security and secure connectivity using TLS between the services. Again, all scripted rather than a human. That's great for speed and our CI/CD pipeline, but the scripts themselves have to be properly written and tested to make sure that security vulnerabilities aren't somehow make their way into production using containers and orchestration. And then the DevSecOps is a large area which for me involves people skills, collaboration on the team between developers and operators in the cloud, and the processes that they use to, and the skills that they use to ensure security. And that also is a challenge. Now, instead of having two teams, a security team and a development team, or an operation team and a application development team, it's one team responsible for the service that they're delivering over the cloud. That requires new skills, upskilling, training, and so on. So that's how we describe cloud native, and beginning to touch now on some of the challenges in securing this modern software factory. Matt? Now, why? Why go through all this hassle? Well, we've talked about it. The reason is to achieve the business benefits. And if you look at companies who have made the leap and have gone now with cloud native, that impressive customer experience that they're delivering and the kind of market growth that they're getting. Uber is kind of the Uber example of a cloud native application that scales, that's providing great service to its customers. And of course, the value of that company is huge. Netflix is one of the early adopters, and there are many that we could name. And the reason they are so effective is because they're built on technology which has achieved these cloud native technology goals. And those then help that company achieve the business benefits. A great example for me, given my fintech background, is what's happening in banking. The challenger banks that have come in now to challenge the high street banks are all built on a cloud native platform. So if you're familiar in the UK with a bank like Starling Bank, the ability for Starling to produce and to deploy new financial services on their platform is so much faster and in some ways easier than say for Barclays to do. And the reason is because they have got a cloud native platform that they're running, and Barclays is still in the process of modernizing, although they're doing a good job, but they're still in the process of modernizing their platform. The resilience and scalability technology goal also is important. Security issues, a security breach is critical, does critical damage to in banking, but Michael, as you said, in any business, retail, your business, it's critical to prevent. We cannot afford, a company cannot afford to have breaches. Notice that also with the improved security in the cloud, by doing this right, a cloud native application actually will be more resilient to security breaches, and also much more scalable, so delivering an improved customer experience. So the reason we're going through this is to achieve those business benefits. Now let's keep going back and taking a look at the challenges. Most companies that are going through this migration to the cloud and then modernization of their software or the creation of new, say, cloud native software will go through a kind of phased approach to it, where in phase one, a lot of the focus is on that microservices piece, or perhaps wrapping a legacy application and then moving it onto the cloud. And kind of phase one is kind of after you've done a lift and shift, where you just take the legacy application and move it from a data center onto a cloud. So that might be phase zero. We could call it phase zero. But in phase one, when we're starting to look at modernizing the application, quite often what we do is we take an application, maybe coarse grain the services, containerize those in phase one, and it's fairly focused on the web application itself. Then in phase two, we're starting now to move into a CI/CD pipeline. We've got the tooling in place to more rapidly deploy the application, and also to manage a finer grain set of microservices in the cloud. And for that, we need clustering and the orchestration that comes through a package like Kubernetes. And then in phase three, we're up and running. And it is a software as service with a team that is now fully trained in delivering that cloud native application or cloud native services with a fully automated tool chain. So when we look at the challenge of secure cloud native, kind of one way that I like to look at it is that we break those business benefits down. You can see on the vertical axis there, speed, efficiency, and agility. But we're focusing on one thing at a time to kind of eat this elephant. So it's a phased approach to getting up the learning curve, but it does require long-term ambition. It doesn't happen overnight. Next slide. Now, I like this slide because when we think about the learning curve, and I've said that, you know, top down, the issue here is complexity, not just in the technology, but in the DevSecOps cycle, and inside that, of course, the people in the process. This is actually quite a good slide in terms of what they call the blueprint to success in moving to a cloud native application, to evolve the DevOps culture. You can see kind of as it goes through, what these guys have done is they've laid out a process for doing it. Now, don't worry, I'm not going to go through the process. Actually, the point of this slide is, despite its detail, and the process for moving to cloud native is actually pretty well laid out, but despite all that detail, you won't find security. You won't find the word security on anything in this slide. It's completely missing. And this is the problem of getting the company, meeting the challenge of security and getting up the learning curve, is that it's complex. It's in a way not front and center as it should be. And teams don't have the tools that they need, in my view, to make it work as well as, say, focusing on Docker or Kubernetes or the CI/CD tools that are available. And that's one of the reasons it's a major challenge for companies, is that it's confusing and there isn't a standard approach. There isn't a set of tools that a CTO can bring to this problem. The next slide, equally challenging. So this is from the Cloud Native Association, and these are all the tools that are available to a team that are working in cloud native. And yeah, there are a lot. So which ones are the right ones to pick? And you can see, if you kind of inspect, that's a little blurry, but inside there, yes, there is a section for security and compliance, and many, many tools to choose from there. The other aspect of cloud native that's important and keep in mind is that to achieve those business benefits of cloud native, we have to achieve those at speed. We need automation in the development and operations. So it's not a matter of assembling a few tools and then it's a matter of assembling a pipeline of an integrated tool set, an integrated tool chain that all work together at speed so that changes can be made to the application and deployed into production very quickly. So it is quite a confusing and challenging ecosystem out there to pick what tools interoperate properly, what do I need, what level of investment is required in the tooling, how can I be sure that I'm not over-investing, and hence the challenge of the tool chain. Next slide, Matt. But it does come down to people, process, and technology. We focus a lot on the technology and the tool chain and assembling that together, and we'll talk more about that, I'm sure. The classic static application security testing code scanners that scan through the source code to identify patterns of vulnerability there have been expanded to include things like infrastructure as code scanners that will scan through your infrastructure scripts, and etc. So we focus a lot on the technology and the CI/CD tool chain, but equally, or even more so, the people skills and the processes that our teams follow to deliver secure cloud native all need serious, in the case of people, skilling and training. In the case of process, a lot of work on the process to make this all work to deliver the secure and robust cloud applications that we've got to get done. So that's a quick kind of context setting.
Fantastic. Thank you, Clayton.
That kind of sets the stage for our.
It does brilliantly. Thank you. So what I want to do now is turn to you, Mike, because what Clayton just described is a journey from where companies were to getting onto this cloud native journey and getting the advantages and the benefits of cloud native. And I know that that's a journey that Travis Perkins have decided to go on and are progressing. So just tell us a little bit more to begin with about, what is the project you've been leading there, and what's that journey been like up to this point?
Yeah, absolutely. Good morning all, and thank you for that lovely leading, Clayton. So as mentioned, I'm Mike Bidwell, Head of Information Security on the interim at Travis Perkins, and their Governance, Risk and Compliance Manager. So just to talk to you a little bit about our journey with GitLab Ultimate to secure our cloud implementations and our sort of cloud native platforms. So as I mentioned earlier on, our strategic business goals are taking us towards heavily integrating on the technology side, allowing customers to interact between our group over the various technology platforms. So as part of our roadmap in the security space, we reviewed and chose to implement GitLab Ultimate package, and that was early in 2022. So to support that, those digital services and those wider integrations, we needed higher visibility. We needed to understand where our integrations were, how our development pipeline, how our CI/DI was working. And as I mentioned earlier on, predominantly being a retail business, we need to ensure we're suitably hardened in our presence in the cloud. Our applications, our ordering platforms are all working to their best efficiency, and most importantly, security as well. So within the group, within our technology services function, we make sure that service and security are at the heart of everything we do. So the challenge we had was that limited visibility and control in our development pipeline. So I'm going to talk you through on the next slide around some of the solutions we use from the GitLab Ultimate package. Just like to move through for me there. Fantastic. So as part of our selection process, these were the key areas that we identified as needing to understand in our cloud native applications and our cloud native technology stack. So looking towards my core area, my governance, risk and compliance, when I put that hat on, I was keen to ensure that vulnerability management was in the solution. So we could provide assurance for our compliance requirements, such as PCI, Cyber Essentials, so all of those areas where we need to have a strong focus, where we can be asked questions on what we're doing in that area, how we're meeting the requirements of those compliance needs. So some of the key kind of areas that I wanted to point out in there that were really really at the top of my list. Vulnerability scanning, making sure we understand what vulnerabilities we had and how the teams were remediating those as well. What are they doing in that space? Are they meeting our KPIs? Where do we need to get in? What governance processes do we need to have a look with them? The other points in there that are quite key to me: dependency scanning, license compliance, and container scanning. So as we move towards those areas, our containers are one of our areas of it took quite a while to bring those up to the level. We're using lots of different containers, lots of different build images, so it took a bit of time to slowly bring those up to the level we needed to. And that's one of those points of visibility. The service area had been a little bit in focus and security had slipped. So we've worked through, and I'll talk to you later on about some changes we made in that area to bring those up to the level where we need to be. And again, license compliance, it's quite a big area now with Cyber Essentials. They are asking the question, is your software licensed and supported? This gives us that visibility that we're missing in the cloud native areas. That was really key to helping me in that space and helping the group provide those assurances. Now, although GitLab Ultimate has provided us vastly improved visibility, I think there's something key here to talk to, and that is that tooling alone does not solve issues around cloud native security. And I think as security professionals, and this is something we're learning in TP, we must push for a security culture that promotes security by design alongside a just culture where people are free and openly allowed to report issues and vulnerabilities. So just in summary on that, so GitLab Ultimate, it's provided us with visibility and accountability over our development landscape. We have a strong governance wraparound, which helps us manage the teams, setting expectations, so we can act as a stress navigator to help them prioritize the tasks where they need to, focusing on the most at risk areas based on what we have in the GitLab solution. And that's been quite key as we've rolled out. Obviously, you have quite a large backlog initially as you start working through those, clearing off the vulnerabilities to enable us to move forwards. And it's been an interesting journey so far implementing this tool set with lots of lessons learned in that space as to the best way to implement this, how to manage the stress of the other teams as you go through this large-scale change from the traditional development methodologies into a method that helps you secure cloud-native applications. I hope that's given you a quick overview of the project.
That's fantastic, Mike. So tell us a little bit about, you started to talk there a little bit, and Clayton was mentioning as well, the the people aspects of it. And in particular, that tension between the devs that want to get stuff done quickly, and we want to move to that model of continuous deployment and development and get stuff out quickly, but also, the security experts who are desperately trying to make sure things are done in a controlled and secure way. How have you managed that and tackled that tension between those two camps in Travis Perkins?
Yeah, absolutely. So we have a number of initiatives in this area. And in fact, it starts much earlier on than some of these initiatives I'll talk to. I think some of the key points is I'm a firm believer in hiring technical experts into the governance, risk and compliance place. So when we're talking to teams, we can talk with the SMEs on their level and act with empathy as well. And I think that's quite key. Some security teams are very linear, very rigid. We need in security to be a bit more empathetic at times, but also know when we need to stand firm when the risk is too great. So within TP, I think some of the areas that we've looked at, we're actually moving towards a professions and teams model within TP. So a team will look after an application or service, and they will call upon resource from the various professions. Now, what this allows us to do is within those teams, we can expand our information security champions program. We can have somebody embedded into each team who takes the lead in that area. They can also help us focus on what training needs those teams have. We then host regular governance meetings in with those teams and with InfoSec champions to make sure that what we're doing is we're driving that security culture I mentioned earlier on. And that hopefully ties us together a bit closer. One of our groups within GTS, Group Technology Services, one of our key values there is being better together. And we take those values and we try and live by them. And that helps us work more tightly as a team, looking at how we can help them, not just on the technology stack, but as I mentioned, stress navigation, workforce architects, helping them with training in those areas.
Awesome. So the cultural piece sounds like you're kind of cracking it, or you're certainly on the right path there. What are some of the other specific challenges that you've faced as you've gone on this journey?
Yeah, so I think in relation to GitLab tooling, it was a fairly fast deployment we've run through. So I think challenge-wise, stakeholder buy-in was key. We were moving from a very sort of fast free release cycle where vulnerabilities could instantly be released into code, and now we've moved into a release cycle where we actively block deployments if there are vulnerabilities above a medium. Any lows need to be authorized first, but if you have a vulnerability medium or above, you won't be able to deploy that until that issue has been resolved. And obviously that does take a little impact onto deployment. But like I said, when you're looking at your reputation as a group, we need to protect that. We need to ensure that what we're doing is safe and secure. So that was one of the key challenges, was that stakeholder buy-in. And that's taken a little bit of time, and that means we need to build our reputation. We need to be trusted advisors into the group to be able to have that leeway. Obviously, one of the key points of this is making sure that deployments can still happen fast, and that's where the automation helps. So that automation around those areas where the developers are getting a self-service platform to see what the issues they have, it allows them to act quickly within their sprint lifecycle. So that really helps them drive forwards as quick as they can. As we know, some of the traditional security methods could take some time to run through, develop, but I think GitLab has helped us drive that forwards. There's also a bit of a learning curve that slowed our deployment out as well, with regards to some of the out-of-the-box functionality in GitLab and the way it works. It assumed that a single CI build is directly correlated to a single Docker container, and that's not quite how it works in our environment. So we've had to make some modifications around that, so we couldn't deploy out of the box. And I think lessons learned, if we were to go through this process again, we'd probably look to adapt our processes to the tooling.
Fantastic. Thanks, Mike. That's a really valuable insight into how TP have been on this journey. So what I want to do now is open up the discussion and start to bring in the rest of the panel. Before I do that, though, I'm just going to say again to the audience, if you have a question you'd like to ask the panel, or you'd like to get them to discuss, or you'd like to contribute to the discussion or make a comment, please use the Zoom chat and I'll keep my eye on it, and I'll try and pick up those questions as we go through. But Sajindra, if I can bring you in to start with. So we've heard from Clayton, we've heard from Mike. From your perspective, what do you see is the biggest challenge when it comes to security in the cloud?
Can you hear me, Matt?
Yes.
That's wonderful. Yeah, that's a great question. So I'll try to grow up based on what Clayton explained about the sort of cloud native model as well. So the biggest challenges, so before, if I may answer the question directly, so let's, if you dissect like the cloud sort of the architecture. I mean, as you know, whether it's private cloud, public cloud, and mostly public cloud that all of us are using, Azure, AWS, GCP, and likewise, that's a shared responsibility model. I'm sure some of you have been hearing this, have read about this. If you take the responsibility of security by the provider of the service, let's say Microsoft, Azure, etc., AWS, versus the user of the cloud, i.e. companies, enterprises, fintechs like ourselves. So all of them have defined a shared responsibility model, pretty much saying what they own, i.e. security of the cloud, whereas the consumers like us, we are owning the security in the cloud. So if you try to differentiate that, security of the cloud is the responsibility of the providers. That means secure infrastructure, secure compute, secure storage, secure network, and secure physical security aspect. That encompasses the whole security offering. But then it comes to how the applications are run, how you store your data, how you transfer your data, how your users access, how the authentication happens and entitlement happens, all sits with the consumers, us. Yes, the cloud providers provide a lot of libraries, APIs, toolkits, third party as well as they're on their own. It's up to us to understand those products and services well in light with a cloud native architecture and start using that. So that's one dimension of a challenge. And the second dimension is, given the fact that you are running on shared ecosystem, what you share can be different, whether if it's infrastructure service, you might be sharing a physical kit running on a separate virtual machine, and then you go to platform as a service, you would be sharing an application space, a container space within a wider application ecosystem. So it can be different levels of abstraction, different levels of sharing. And that brings the notion of this zero trust architecture. So zero trust architecture means just because you authenticate a request or a user at one point in time, that doesn't mean you can trust that request or the user. It doesn't matter if it's a human user or a system user. So you need to continually authenticate and authorize and verify each request across each layers of the architecture. Let it be through a firewall, an API gateway, end user, let's say a proxy application running on a container. So it doesn't matter. At each level, there needs to be verification done. So checking in depth of vulnerability checking, access checking, entitlements checking. So that brings in a lot of additional work and a lot of complexity when you run on a cloud native environment. And also the scale can really grow if you have cloud scale. So when Clayton explained about microservice architecture, the Docker setup, all this brings scales and agility. And you can massively scale thousands of services like Netflix, Uber, they run thousands of services. They deploy everything 100 times a day or like 1,000 times a week. So all this brings a lot of complexity. So all this with complexity brings a lot of challenges with respect to how we manage security, how we do not trust where your code running, and which containers, which orchestration layers. So all this brings different challenges. Of course, there's no free lunch. Yes, you bring a lot of agility, time to market with cloud native solutions. With that comes with the different realms of security you definitely need to address. So those are the key things. So zero trust security running on a shared responsibility model and looking at how you secure at code level, container level, infrastructure level, network level. So those are the key dimensions I would think everybody should start thinking of.
Fantastic. Clayton and Mike, do you agree with that?
Yes, absolutely. And I think one of the key points around that shared security model is making sure you have a clear understanding of what your responsibility is in that model as well, because it does vary heavily sometimes between providers, applications, SaaS, IaaS, PaaS. Having that understanding clear from the beginning is absolutely key to securing of your service. And a mistake early on can prove very costly down the line as you're suddenly going back and looking at tooling to close a gap, or looking at a potential breach that's been caused by a misunderstanding in that area. And it's very good to hear that everybody else as well is looking at that area as a key starting point when you're sourcing these cloud services and providers.
Yeah. Clayton, from the perspective of the development teams themselves, what do you see the challenges for them from their perspective when you're modernizing to cloud native?
Thanks, Mike. Yeah, and also kind of linking back to what Sujindra and Mike were just talking about, a good example is in what I refer to as infrastructure as code. So in infrastructure as code, we now have a developer who is writing a script that will launch inside the cloud service provider to spin up the environment, and then they'll deploy their application to that environment. Now, the operations team used to do that. It wasn't the development team that spun up environments. The development team might send in a request to the operations team to get a test environment set up. But now the development team actually can write a script, launch it into AWS, and have an environment in 5 minutes. So it gets to a little bit of what Sajindra and Mike were both talking about in terms of who's responsible for the security of that. Certainly in the past, the operations team was responsible for securing the environments that they spun up on the cloud. Now we've got a development team that's writing the script, that's spinning it up, no operator involved. And that is a real challenge, and one that that we work through actually as part of our journey, because from an operator's perspective, I focused on them a bit more than the developer. See, the operations, even 10 years ago, is almost a craft. To be a very effective operator in an operations center, in a service operations center, you need to know how to set up an environment. You need to know where the tricky issues are, and securing that and making sure that your keys are in the right place and that you've got TLS set up properly. And all the problems sometimes that you see with the infrastructure has to do with the complexity of setting the configurations all up correctly and done properly. Now, a lot of that's being done in a script. And so what about that knowledge, which is currently in the head of the operator, and the security responsibility is now shifted over to a developer who actually knows about code, but doesn't know about configuring the operation. So interesting thing to work through. And Mike, I think as you described the TP approach to a team that is delivering the service, so that's one team with professionals that come in to advise and to help to make sure it's properly done, is a great solution to that challenge. And something similar to what we did, but it's a change from the 2 or 3 team security, ops, and development to a single team who is focused on delivering a service to the end user, and that service has to be secure. So lots of challenges there in terms of teamwork and making everybody feel that their knowledge is still very valuable and being used to deliver a great service to the end user.
What other ways do you need to shift the culture, Clayton? Yeah,
so kind of a follow-up there, and Mike, I think you referred to this too. So perhaps it'd be interesting to hear your view on this. You kind of saw that in the diagram that I briefly kind of showed, where security wasn't even mentioned. Application development has been very focused, well, shouldn't be now, but very, very focused on the customer experience or the functionality or maybe the performance of the code. And yes, there was always a user login screen and passwords that had to be handled, but the developers, once that's done and you're inside the business application, the developer didn't need to worry so much about having a secure session. That was already taken care of. And as Sajindra pointed out, under Zero Trust and the way these services now are deployed, that's just not good enough. You have to be concerned about authentication and authorization in every service that you build. You can't depend on, say, the infrastructure for securing it. So the culture, overall culture, therefore, has to put security actually ahead in some sense of things that used to be like the user experience or the performance of the software. It's now at equal status. There isn't a separate security team that comes in and checks. It's definitely now at equal status. And so it is a cultural change. It's about training, making sure that people understand how they contribute to the security of the overall service that's being delivered, how we're working together now across what used to be silos. So it's breaking down those silos between the security team, ops team, and dev team to have a single team. And continuous communication about how to effectively meet this challenge is part of that cultural change. It's not something that, as I said, is once or done. You can't switch flick a switch and have it change. It is a journey that will take a number of years, I think, for us to fully realize.
So, if I may add something to that,
yeah, please do,
Sujendra? Yeah, so I think the one of the other aspects is beyond the cultural change, more of the shift in the architecture has resulted in the need to left shift the security profile or the security focus. So imagine like 20 years back, people used to write monolithic applications. So the authentication, the security check was when the user logs in, and that's pretty much it, right? But when you move beyond that to a more microservices, containers architecture, you lose that control of managing a monolithic application. Of course, you lose your complete agility and speed of that. So adopting a microservice architecture requires securing that container, the code itself. So there is a pretty much inherent requirement for the developers to understand how to secure his or her code or that particular pod's container. So it's pretty much a mandatory requirement now for developers to understand what's the security posture, what are the attack vectors with respect to how my code runs from a static and dynamic code perspective, and make it secure. Because if you go to the DevOps or DevSecOps, they would not know how the internals are built. They would not know it's encapsulated within the container itself, because we are talking about immutable containers. You bring them down, bring them up when you want. So there is an inherent need to left shift the need to incorporate security upfront into the design, the development of software, because of the nature of the cloud native setup. So I think that comes as part of the whole architecture mindset and the whole change in the way we build software.
That brings me nicely on to Sujendra, a question that I was sent ahead of the session actually by somebody, which was, what specific skills should my developers be acquiring as they make this transition? Are there specific new skills they should be learning?
I think it depends on the maturity of where you started developing software as well. So yes, let's say a developer comes with strong design and development expertise on a particular language, particular functional domain. I think the main aspect that would help personally as well as the organization would be moving left shifting the security focus, the knowledge and the understanding of how I can make my code secure. Am I using the right libraries that are secure? If I've done it from something from open source, has it been ratified? Does it appear in any vulnerability reports? Have I done a SCA analysis, dependency analysis? And also the understanding of how to instrument and profile the runtime environment from a security point of view, not just from a performance point of view, but from a security point of view. It's really key. And also how the application or the code can run in a secure containerized environment, and what mechanisms it should expose to the underlying infrastructure to monitor. So for example, if there is any vulnerability attack, how can that be exposed to a monitoring platform, a telemetry platform that can be alerted to a production support, security support, DevOps, DevSecOps pipelines. So I think those are the key things I would assume beyond understanding cloud native and how to use cloud native technology. I think that's moving the security focus at the point of development is really key, and will be a differentiating aspect as well.
Mike, have you seen any kind of additional specific skill needs that you've had to get your developers trained up on?
Yeah, absolutely. I mean, one of the key things that I like to focus on with developers who are working in that web space is looking at the OWASP toolset, running them through there, helping them to understand the type of attacks that there can be and how to defend against those. So we're starting to develop cheat sheets in each area, okay, you're developing with APIs. What do you need to do? What are your baseline control sets in these areas? And I think development has very much over the years not had a heavy focus on security as it's being taught. And I think that's been the way for as long as I can remember, certainly, that there hasn't been that teaching. And I think that's slowly starting to change a bit now as GDPR and things along those lines come in, and there's a legal requirement for privacy by design as part of that framework. We need to start changing our approach. We need to have buy-in. And I think we need to give the tools to do it as well. So OWASP is one of my kind of go-tos, but again, that move that we're making to professions and teams will allow us to be much more focused and target our training. And it's very difficult to make it relevant for an entire group. We have a wide technology stack, so we need to focus in on the areas where we are. And we love knowledge sharing. It's something else that we try to promote is, we have knowledge, let's share it with you. Let's hold internal lunch and learns. Let's drive this through. And it just builds on that culture, that drive for people to be secure.
And are there any particular tools or methods that you've seen, Mike, that had the greatest impact on security in TP?
So I certainly think GitLab for us in this space and for what we're talking about today has been absolutely instrumental. We are early in this journey. As we move through it, it will be continual improvement. It will be that life cycle. As I mentioned earlier on, the visibility we have gained is just something that you couldn't imagine. We have our internal visibility was good. Our cloud security almost at times felt it was on a little freight train running away from us. And we've kind of managed to pull that back now. We can see what's happening. We understand where things are going. And we can understand the gaps a little better as well as to what do we need to teach the developers. Where are we seeing, not necessarily mistakes, but where are we seeing areas of weakness that keep coming back up? Develop that communication. So GitLab, especially around the vulnerability management, the container scanning, those have been the two areas in there that are absolutely fantastic. And as we move forwards, we're looking at increasing our SASE tool set, those kind of areas. Looking at CASB solutions and finding the what's best for us, what's going to work with our distributed architecture, what will fit, what will help us secure our space in that area.
And do you think, Mike, and I'm interested to hear from the other panelists on this question as well, but I'm going to ask you first, Mike, do you think the way that we do software development has become more or less secure over time?
So I think in the last few years, particularly again to come back to GDPR, I think that has started a movement and started a drive. And that is that drive of companies moving towards that culture. We've seen health and safety do it over the last 30 years. Yeah. And let's be honest, that was driven by monetary fines. We're now seeing similar fines, if not greater fines, within our space, within the technology space, within that data space. And I think that's now making it a board level item. It's not really acceptable now for development of directors to say, we're not training our teams, they're here to code, that's security's problem. It's everyone's responsibility. And I think that's now kind of changing. As I speak to sort of some apprentices coming through, looking at development routes within TP, they are now having a bit more focus. So I think there is a gradual improvement. And I think it is closing that gap slowly, but we all need to change our approach and look at what we do. Look at those training opportunities. OWASP Top 10. Look at where we can automate our security controls to support that software development lifecycle at the speed that people expect it to be available at as well in that DevSecOps space. So I'm keeping, maintaining those areas, helping. And I think we're on the right direction. I do think there is still work to do though.
Yeah, for sure, for sure. Clayton, what do you think?
I think Mike's making some great points there. Maybe to build on that, and I completely agree too, GDPR and it's kind of driven top down has made developers more aware. Obviously we're all aware, but developers are much more aware of the security concerns. The other thing though, as we look at developers, new guys joining, the new people joining the teams, but even the senior developers and architects, these are engineers that want to build great software. That's what motivates them. That's what gets them up in the morning. And building great software today means building secure software. It's now a part of the engineering discipline. And to master that discipline, to understand how to secure the software and to secure it in a modern way that Sitchinder kind of described for us. So I see that across the board. And as I talk to teams too, it's interesting, Mike, that you made the reference to health and safety, because for me, there is definitely a connection. This is customer data. And as engineers, we have a responsibility to protect that. If we were in the automotive industry building an automobile, as engineers, we'd build a safe car. We'd be proud of the car because it was, and it's similar with software. We're building secure software because it's what our customers expect and it's what they deserve from us as engineers. And I see that attitude more and more, let's say, across development teams are aware of it, proud of security competency as a key skill in the engineering discipline.
And Sujendra, what about you?
I think to answer your question, are these software becoming more secure? Yes, definitely. Yes. So for the last 20 or so years, I have seen leaps and bounds in growth in how tech security has taken a critical role with respect to getting incorporated upfront into the architecture and development. Again, not because people started thinking differently, but the new technologies, the way we adapt technologies, cloud-native technologies, has opened up new attack vectors, new security vulnerabilities, and more openings for hacking. And likewise, that has opened up more focus on security. And also, like any other computer science area, the available tooling has been really helpful. Like Mike was talking about GitLab. Likewise, there are significant amount of whether it's static code, dynamic code, or profiling, dependency analysis. But it doesn't matter whether it's network storage, application, infrastructure layer. There's significant amount of products that that are available, readily available and easily usable and integratable to development processes, not just the deployment and production support stack. So the whole focus has shifted left. So I think all those has resulted in actually like improving the security profile of application delivery and development.
I've got a great question that's come in prior to the call. It's a little bit of a cheeky one, but I'm going to go to you first on it, Clayton. This will probably be our last question. But so what's next after cloud native? So 6-7 years ago, none of us were thinking about cloud native. Now everything's piling into cloud native and DevSecOps and so forth. But what's next? What's coming over the horizon?
We've got to figure out cloud native first, don't we, Matt? But and who knows? I guess what comes to mind is probably in scope for cloud native, but maybe not something that we've talked about today and is another type of challenge. And I think the industry term that you might use for that is edge computing. Okay, so we've been talking about web application and cloud, and what we kind of have in mind there is, yeah, okay, you've got a browser-based, say, software as a service, and it's running on AWS in the cloud. And then a good question would be, so what about mobile apps and their security? And how does that work with the web application that you're building through a CI/CD pipeline? What about mobile app deployment? Is that all connected? Do we have the same testing tools for mobile apps that we do for web applications? And the answer is no, not necessarily. So, and then with edge computing, and it gets kind of technical, so maybe you guys can help me out here, but the way I look at it is that our approach to security does tend still to look at a single application and securing that. And what we know is that we now have an ecosystem, let's say, of services that are all kind of containerized and work for a single application, but think about an ecosystem of applications that are running together. So an example might be single sign-on, which is an early stage of this distributed security system across an ecosystem of applications, some of which may be running on edge computers like mobile phones or other devices. So anything out there, let's say in the wild, that still needs to be authenticated and authorized. How do you secure that ecosystem? I think is kind of where we're headed next with this challenge. The cybersecurity mesh is new, and it's an approach to distributing security, let's say, across the edge and across the ecosystem, and something that we'll probably be looking at going forward. But I'd be interested in
Mike and Sajindra, what do you see coming next over the horizon?
So I think, sorry, I just jump on. So I think for the last like maybe 10 years, what we have seen is the layer and layer of abstraction on top of each layer. So when cloud public cloud starts, it was more of infrastructure as a service, how you virtualize the storage, compute, network layer. And then the second age of the cloud was pretty much talking about platform as a service, how we can provide a application as a container. Then it evolved to developing our own containers likewise. So, and then pretty much the SaaS came into picture. So the level of abstraction is going up and up. So you abstract the infrastructure, you abstract the software services, you abstract the applications now. So I think that will continue to grow, and the barriers to entry into technology is going down dramatically. Just purely talking from the technology adoption and the proliferation of simplicity, and also the other directions, like the significant shift towards low-code, no-code platforms has grown massively compared to, let's say, 20 or 15 years ago. And that's, I think, one shift. And the other thing I'm personally curious is about the fundamental computer architecture hasn't changed for the last, I don't know, 60 years. The von Neumann architecture is the same as that was defined in the early 50s. So I think I'm personally quite keen about how the whole dimension changes quantum computing, right? How the security realm will go into a different spin, I guess, with quantum computing, because that will expose different opportunity, how you compute, how you store, as well as open up a more opportunity for how you hack into things through the different. So I think that's I think as personal as my thinking.
Yeah, absolutely. I think the quantum computing space is going to prove exceptionally interesting as it comes forwards. And what I find even more interesting at the moment is how we're already kind of trying to outstrip it now. So they're looking at cryptography standards that can stand up to quantum computing for enough time for them to still be relevant. And the fact we're sort of developing that now shows how much of a drive there is towards security. I'm just going to touch on some points that both Clayton and have made around that. I think we need to look as well, coming back to something I mentioned earlier on, our visibility. How we manage our visibility, how we provide assurance back to our boards of directors. And something that we're finding at the moment is looking at what we can do to give that single pane of glass across our technology stacks as to what we're doing in each area and how we're doing it and how teams are performing. And I think that kind of visibility, as we move to more dispersed technology stacks, and I think that will still be a move for a while until we consolidate back, is how do we get a single sort of view? How do we monitor that? How do we look at it, and how do we report on it? Because we end up with such a dispersed tool set. Getting that information either becomes a manual process, at which point it starts to show the cracks and fall over, or again, we look to automate that and pull everything into that single pane so we can give the board, we can give our senior team leads the assurance they need, and those teams as well. Hey, you're doing a good job, or hey, you need to improve here.
Awesome. Thank you so much, panel. That was fantastic. I'm going to close the questions to the panel there and just say thank you so much for your sharing your insights and your wisdom there. Some absolutely incredible nuggets in that. So just to summarize then on the journey that we've come on, we've thought about how we're moving to this cloud native world, and actually that confers lots of benefits and advantages in terms of speed and agility and deploying quickly and being able to innovate very, very quickly. But it brings with it new challenges, new security challenges, new vulnerabilities that have the potential to be really quite disastrous and serious if they're not addressed. And we've thought about what are the challenges, the specific challenges and approaches to how we can deal with that in terms of technologies and tools, but also in terms of people and skills and culture, and how it's as important to focus on those things as it is to focus on getting the tools and the processes right as well. And then finally, as Mike was just finishing there, having the right governance and structure and visibility in place also make sure we get this right. So that's going to conclude our session for today. Next time, we're going to be getting together again with a slightly different panel, and we're going to be thinking a little bit more in depth about specifically those tools and the tool chains that were mentioned earlier, how those can support creating that right security environment and that right security process as we go through the whole cloud native development and DevSecOps process. So with that, I'm going to say thank you again to our panel, thank you to our audience for joining, and hopefully speak to you and have you on our next session. Thanks very much, everybody. Bye-bye.
Yeah, thanks, bye.
Thanks, Matt.
Thank you. Bye-bye.
Yeah.